Hello friends, this is Dalpat Sonagra, Assistant Professor in Computer Science Engineering Department, Government Women Engineering College, Ajmer. In this lecture, we discuss simplification of context-free grammar part 2, that is about the removal or elimination of those variables and terminals that not derived in sentential form. And this lecture is in continuation of my previous lecture about the simplification of context-free grammar part 1. So let us first discuss what actually meaning of sentential form. So we consider we have given a context-free grammar G, which described by 4 tuples, and we consider any string alpha which is belongs to the set of variables union terminals asterisk. It means alpha could be any string over the variables and terminals. Sometimes it is purely over the variables, sometimes it is purely over the terminals, sometimes it is combination of both variables and terminals, or sometimes it may be null. And if this alpha string derived after the multiple transaction from the starting variable s, then this alpha is said to be in sentential form. And in the steps from initial variable or starting variable to this alpha string, if any of variable and terminals occur during the derivation, then those variables and terminals also known as in a sentential form. Therefore, in other words, we can understand like this: a variable and terminals are said to be in a sentential form if and only if they occur at least once in any of the derivation. Any of the derivation, any of, and for any string derivation, for derivation of any string also. Okay, hope you understand this. So here we discuss how we construct the simplified grammar G1, that is equivalent to grammar G and containing all the variables and terminals that are used in deriving sentential form. For this, we consider a theorem second, where G is given with these 4 tuples, and we have to construct a simplified grammar G1, where the set of where the v1 is a set of variables or a simplified set of variables, and the sigma 1 is simplified set of terminals, and p1 is a simplified set of production. So our goal is to construct this simplified or sometimes this reduced grammar G1, and all the variables and terminals in these two sets are used to deriving a sentential form. So let us discuss how we construct this. So we assume a grammar G is given to us, and correspondingly we construct this G1. So before constructing this G1 or the tuples of V1, sigma 1 P, we have to construct the set Wi recursively, where I is greater than or equals to 1. And initially, um, This is not true for this case. This is not true. Please cut it. Initially, this W1 consists the starting variable. Okay, and set of this set wi is constructed recursively. So in initial wi, when I equals to 1, then it contains only a starting variable of a grammar g, after that we construct w2. Okay, from wi plus 1 means 1 plus 1 and so on recursively. So once we created this wi which contain only starting variable, then we go for wi plus 1. Okay, we will discuss this same theorem with example in our next slide. First we discuss how we construct this wi plus 1. Actually, this wi plus 1 is the union of previously created set wi and the set of symbols x, and this x is belongs to v union sigma. Means x could be either variable or terminals. And how we choose this variable and terminals from a grammar g, because this x is belongs to v union sigma. For that we choose a production a tends to alpha in a grammar G, where of course A belongs to only a previously created set Wi. Okay, if we are working here and W2, then this Wi is W1 like this. Okay, so this A means A is what the variable which is in a left hand side of your production. And of course we know that in a context free grammar, left hand side having exactly one variable. So this variable is should be belongs to this previously created set wi, and this alpha means right hand side of your production in a grammar g is containing the symbol x, which could be anything from the set of variables or a terminals in a given grammar g. Okay, note that Wi is a subset of V union sigma derived recursively. So this Wi is always a subset of processor or a successor set of symbols Wi plus 1. Means if W1 is always a subset of W2 and W2 is a subset of W3, for like this for all I, and as I is less than equals to the number of variables and the number of terminals. Okay, and we know that the V is a finite set. So sometime we reach to a situation where a Wk is equals to the Wk plus 1. Means sometime we reach to a situation where the previously created set Wk is equals to the next created set of symbols Wk plus 1, and where k is less than equals to number of variables in a given grammar G. So by this we receive one set Wk, which is the set of symbols from the variables or terminals. Okay, after the construction of this set Wk, we proceed to construct the simplified set of variables, simplified set of terminals, and simplified set of production. So we have a Wk. Okay, so we discuss how we construct the simplified set of variables. For that, the the simplified set of variables v1 is actually the common symbols between common variables in between the set of variables which is from previously grammar G, and this is our new set. Okay, so this is v1 is a set of common variables in both these two set. Okay, we will discuss the same thing in our next slide. After constructing this, we go for the construction of set of production, means simplified set of production, and that is constructed, of course, uh, like this: a tends to alpha, where a belongs to, where this a belongs to v1, where this a belongs to v1, and alpha belongs to wk, and alpha belongs to wk. Okay, you can write a belongs to wk, this is also right, but more precisely you can write a belongs to the simplified set of variables, and alpha belongs to the set of wk. Okay, after construction of simplified set of production, we go for the construction of simplified set of terminals, and of course that is also the intersection, not union. This is the intersection, of course this is the intersection of the set sigma and wk. Okay, so this is simplified set of set of terminals. So after constructing V1 and sigma 1 and P1, all these are simplified, or you can say reduced set, corresponding to a grammar G. Then we can define a grammar G1. This is known as simplified grammar, in which all variables and terminals deriving some sentential form. And one more thing, the language corresponding to a grammar G should be equivalent to a language corresponding to grammar G1. The meaning is that if we construct a simplified grammar G1 corresponding to a grammar G, then the language which is derived by grammar G and a language which is derived by a grammar G1 should both equivalent to each other, means both derived or define the same set of string which is accepted by both. So let us discuss this theorem with one particular example. So here we have a grammar G and productions are like this. Okay, there are four productions. First, second, third, and fourth. And corresponding to this grammar, we have to construct this G1, which is simplified, and in which every variable and terminal should derive a sentential form. So first of all, we discuss a set Wi recursively, where this I is greater than or equals to 1, and stop up at a particular wk where the wk is equals to wk plus 1. So initially w1, according to the previous theorem, this is the set of starting variable. So in a grammar G, s is starting variable, so include s. Okay, so next we construct recursively w2, which is the union of w1, this is w1 set, and the set of symbols from the v union sigma. where 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 uh, we construct this set of symbols by choosing the production in a given grammar G, where this A belongs to Wi and alpha belongs to any symbol from V union sigma. So in this case, this set is of course what A and B. How it is? Because we look the production in a grammar G. In a grammar G, we look this production in a grammar G. So if we look at this production, then here this A is what belongs to W1 and W1 is what our S. So this is S, okay. And the right hand side is what? The right hand side is a, a string having the symbol from V union sigma. So in a grammar V union sigma, A and B are what? AB is what? Belongs to the set of variables. Therefore, we choose the symbol A, capital A and capital B into this set. Okay. This production is not, because this A is not belongs to the W1, because there is only A, sorry, there is only S. Therefore, we not use this production here, not this production here, and not this production here. So hope you understand why we choose this capital A and this capital B. And once this is understand, then we take the union of both these two set, which is this. Hope you understand this. Okay, if you understand this, then we go recursively to construct W3. And W3 is constructed recursively by the previously created set W2 and the set of symbols like this. Okay, in this we choose those symbols which is come into the production where left hand side is belongs to the W2 and the right hand side belongs to the symbols from V union sigma. So when we look at the productions, so if we look at this production, first we look at this production, then S, capital A and capital B already in the set W2. Okay, so we choose this as capital A and capital B like this. Next we go for this production where A is already in a W2 and this small a is belongs to V union sigma. Therefore, we include this A into our set like this. Okay, after that we go for this production. This B of course belong to W2 and which is already in a set W3. Okay, next we include this B symbol because this is belongs to V union sigma. So we include this B also according to this rule. Okay, so when we look at this production, where 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 according to this, as per this rules, this A should be belongs to previously created set W2. So this E is not belongs to W2. Therefore, we not include this capital E, and because of this is not the A according to the rules, therefore we not include this thing also. Hope you understand. Because this is not belongs to W2, therefore we not include this small c into our set. Hope you understand. Okay, if it is clear, then we can say this is a set W3. Okay, then we go for set W4. and when we construct this is equals to W3. Okay, you can try, you will never found anything, because a W4 is like this. W4 is equals to a W3 and union with a new symbols. But this is what a null set. You will find this is what null set. Therefore, W4 is equals to W3. Okay. Okay. Therefore, this W3 is equals to W3, and which is what? S, E, B. These are the variables, and small a and small b are the terminals, and this set is known as WK. By using this WK, we will construct the set. Sorry, this is not like say this is construction of V1. Okay, so by using this WK, we will construct this set V1, and V1 is what? Intersection of V and WK, where V is what? S, A, B, E according to the grammar G, and this is set WK. So the intersection is what? S, A, B. So the simplified set of variable is V1. According to this, after this, we construct the set of production to then P is what? The production of the form A tends to alpha, where A belongs to the set of simplified set of variables V1. Okay, so if we look at this production, this is belongs to V1, and then we use this, and alpha should be belongs to WK. So A and B both belongs to WK. Okay, WK. Therefore, sorry, this is the WK. So we include this production into our simplified set of production, and this is also included because A is belongs to V1 and small a belongs to WK. Of course, we use this production, and of course, after that, this is we also include because this is belongs to V1 and this B belongs to WK. But note, this is will not include because E is not belongs to V1 and small c does not. Therefore we will not look over the right hand side. Okay, no need to look at right hand side. So this is the simplified set of production. And now we construct the simplified set of terminals, which is the intersection of E and WK. So sorry, sigma is A, B, C, and WK is S, A, B, small a, and B. So the simplified set of terminals is this. So by using this simplified set of variables, simplified set of production, and simplified set of terminals, we are able to derive the grammar G1, that is known as simplified grammar, corresponding to a grammar G, and where the both the language of grammar G is equivalent to a language of grammar G1. You can check. Thank you. If you understand this, if you have any query, then you can mail me at this. Thank you.